Yeah, that's it. That's our last resort. Okay, so guys, let's go over page. We shall start. It is the last place I left off, I believe, is page 24, number 7. Guys, got to move you off your computers. Don't need them. Yeah, number 7. That's where we left off. For the workbook. Number 20, or number 7, page 24. Okay, so it says here on page 24, it says in 4 o'clock flowers, the alleles for the 4 o'clock flowers express incomplete dominance, which means there's a blending. Codominance would mean there's separate colors. Incomplete means they blend. Normal dominance means one dominates over the other. You don't see the recessive one. Okay? So, it says here, what are the genotypes, first of all, of the parents? A red flower is crossed with a white flower, and you get the intermediate. If it's a red and white flower, then you must have the following genotypes. I'll show you why. I'll show you the outcome. Here's my very rough Punnett square. I have to start off with the following. FR, FR, and FW, FW. Okay, guys, I don't have the time. This is being recorded. I don't have the time for this. I'm moving you in a second here. I really am getting impatient. Okay, so we cross. We can start with the columns or the rows. I always start with the column. It'll still work out. So you get with the first column FR, and then FW with the first row. First column again, FR. Second row, FW. It doesn't matter what the order. It doesn't matter what the order of the alleles are. Okay, so for this one here, the alleles are in the same order, but you could have FW, FR. It would be the same pair. The order of the alleles doesn't matter. FR, FW, or FW, FR. Okay, let's complete this. We have, starting with the second column, FR, first row, FW. Notice they're in a different order. It's the same pair. The order doesn't matter. And then for the last pair, FR, FW. Okay? So in all 4 cases, you end up with a blending pink. All of them are pink. FR, FW. The genotypes of the parents are this. FR, FR. And FW, FW. That's the genotypes of the parents. Just going to quickly check next door. Okay. Next, that's part A. It's just asking us for the genotypes. Part B. What's the genotypes of the pink flowers? Genotype of the pink flowers in the first generation is FR, FW. Okay, it's an incomplete dominance. You need both alleles to form the blending of the colors, pink. C, 2 pink flowers and then cross. What are the possible genotypes? Let's see what we get. We'll find out what the genotypes are and then the phenotypes. Okay? So pink flowers are FR, FW. And we're blending two of them. So two FR, FWs. That's the crossing. That Punnett square shows the crossing of the two pinks. So FR, FR. FR, FW. FW, FR. Again, the order doesn't matter. It's the same thing as FR, FW. And then finally, FW, FW. So the question is, what are the genotypes? The genotypes are the following. I'll try to make them different colors. You have 1 out of the 4 is FR, FR. That's 25%. You have another set of genotypes here. Again, the order doesn't matter. FW, FR is the same thing as FR, FW. That's 2 out of 4, 50%. You could guess. You could express it as a fraction or a percent. Okay. You don't need your computers over this, right? You're working on your workbooks. And last but not least, I'll make this a different color. 1 out of the 4, well, that's a different color. 1 out of the 4, or strange. 1 out of the 4, or 25% is FWFW. That's the genotypes. Phenotypes. Phenotypes, FR is red. FWFW is white, so 25% of each. Right? So I'll write it down. 25% is red. And in no particular order, 25% is white. The yellow and the pink, those genotypes code for red and white respectively. And then the remaining 50% is pink, made up of the F, R, FW. Again, the allele order doesn't matter. Okay, 8. Read it to yourself. I'll go through it in a sec here. So this has to do with colored rabbits. Okay, and I'll cross the gray with the white. We need a Punnett square for that. So the gray is HB, HW. That's the gray. That codes for the gray, right? The gray it's incomplete, so it's a blending of black and white. And then we're going to combine that with the white rabbit, which is HW, HW. Okay. So I usually start with column, row, row. So the first column, HB, HW, and then again, first column, HB, HW. So far, grays. Next column, HW, HW, white. And then HW, HW, right, white. Okay? So the possible genotypes. The allele formation, what the alleles look like. 50% of each. HB, HW. And then 50% HW, HW. Okay? Any questions? Number 9. Flower color is determined by incomplete dominance in one species. It's crossed. We have red, true breeding red is crossed with a true breeding blue, which means what? True red is FR. True blue is FB. What two flowers could be crossed to result in 50% chance of producing purple flowers. So when you cross the FR and the FB, you get FRFB, 50%. We're aiming for 50%. We want 50% of the alleles being FRFB. Let's see if these work. This is trial and error. You may make some mistakes. These two should work. But again, it may require a little trial and error. So we have, let's try this out. FR, FB, and FB, FB. Let's cross those. So you get the following. FR, FB. That's one purple. Again, FR, FB. So far 50%. We can't go over that because we're aiming for 50%, no more. FB, FB. That's blue. Perfect. So far so good. And then FB, FB. Perfect. That gives us 50% purple. The rest are blue. So that's 50% purple as intended. Next. Again, you may make mistakes. It's not a big deal. You just try it a couple times until you get the right configuration. I'm making it easy. I'm giving you the right, but I'm showing you that it does work. Okay, so what's the next combination? I'm going to show you this works. FR, FB. So far the same as the top one, except now we're going to switch this second combination to FR, FB. Let's see what happens. Cross the first column with the first row. You get FR, FR. First column with the second row, FR, FB. There's our first purple. Next, second column, FB, FR. It's the same, there you go. It's the same thing as FR, FB. The order does not matter. FB, FB, there you go. There's your 50%. That works. There's one here. That's an FR, FB in a different order. That's an FR, FB as well, meaning two purples, 50% purple. Okay. Next, page 26. Number 1. I think I just had to do this, and then 30 to 32. We'll get to 32 in a second here. Number 1, page 26. Define a sex-linked trait. It's a characteristic controlled by the genes located on the sex chromosomes, the X and the Y. Okay. So it's genes. This is the main point. Located on the sex chromosomes. Okay, 2. We have consider the X-linked trait of hemophilia. It's a blood disorder. What's the genotype for each of the following individuals? A man with hemophilia. Okay, so a man with hemophilia, obviously he's going to have X and Y. It's the X chromosome that comes from the woman, so that must be the carrier for hemophilia. It's a recessive trait, so it's lowercase h. If it was uppercase H, he would be normal. Okay? It's not on the Y because these are sex-linked traits. It's brought about from the X chromosome from the mother, in this case. B, a woman with hemophilia. A woman has two X's. Can't be uppercase because she's not simply a carrier, she has it. So she must have two lowercase. It's a recessive trait. In order for it to appear, she must have two lowercase. If she had this, if she had one uppercase and a lowercase, she would simply be a carrier. It would not appear. For a woman, you have to have both alleles with the recessive trait. For a man, you only have to have one of the chromosomes showing the lowercase h. Okay, C. A man with normal blood clotting ability. A man is XY. The sex-linked traits are determined by the X chromosome, so he's not hemophiliac, it's an uppercase H. Okay? It's a recessive trait. It's not as common. A recessive trait is a lowercase h. A dominant one that's more dominant, occurs more often, is an uppercase letter, in this case H, standing for hemophilia. In this case, not hemophilia. D, a woman who's a carrier. Woman is XX. Carrier, what I drew here. Big H, she's a carrier. She has a recessive little h. E, a woman who is normal and not a carrier. XX, X big H, not a carrier. 3. Read over 3. I'll read it to you in a second. Yeah, you may. Okay. A woman who's a carrier for hemophilia marries a man with normal blood clotting ability. What are the possible genotypes and phenotypes of the children? I'm going to use a Punnett square. Okay, let's start with the woman. The woman is a carrier. We already know. First of all, she's XX. She's a carrier. So it's big H, little h. She's just a carrier. She only has one little h. The man that she's married to, he has normal blood ability. Man is always XY. It's the X that designates whether he's hemophiliac or not. He's normal, so it's a big H. Let's cross. X, X, big H, big H. That's the first column, first row. First column, second row. X, big H, and Y. So far, no offspring that are hemophiliac. Next, second column. X, little h, X, big H. Again, a young baby girl who is a carrier. No sign of it. Next, X, little h, there you go, and a Y. That's the male. He's a hemophiliac. Okay. Yep. So, the question is, what's the genotypes of, what are the genotypes of the offspring of the children? We have the following, 25%. Let me go through this with different colors. So first of all, 25% X, big H, X, big H. 25% X, big H, Y. 25% X little h, X big H, and then 25% X little h, Y. There is no, I'll write this down for clarity, and I'll write these all down in a second, but I wanted to highlight this. 0% X little h, X little h. There's no baby girls that are hemophiliacs with this combination. One possible male that's hemophiliac. So let's write this down for clarity's sake. 25% X, H, X, big H, both of them big H's. 25% X, big H, Y. 25%, 1 out of 4. You can use percentage or fraction. X, X, little h, big H. And then 25% X, little h, Y. The only hemophiliac is the possibility is the young baby boy. And then 0, again, for what I wrote above. Zero chance of getting a baby girl who's a hemophiliac. Okay? So that's the genotypes. In terms of phenotype percentage, as I said, it's only this one here. If we go back to the top, 1 out of 4. Let me finish here. 1 out of 4, or 25%, is hemophiliac. In this case, it's a baby boy. The other remaining are non-hemophiliacs, whether they're boys or girls. 75% are not. They have normal blood clotting ability. Okay? I'm sending messages to other people. I don't know, man. I don't know. You guys are watching me, some of you. Fine with me. Let's go over page 30 to 32. One. One is H. I should write this down. Page 30. One is H. 2 is A. 3 is B. 4 is F. 5 is E. 6, I'll go back to the top here. 6 is I. 7 is G. 8 is D. 9 is C. 10 is C. 11 is C. 12 is C. And 13 is A. That's the first page, page 30. Okay, page 31. 14 is B. 15 is B. 16 is D. 17 is D. 18 is C. Yeah? Second to last page, page 32. 19 is C. 20 is D. 21 is D. 22 is B. 23 is B. And then last page, 33. I think I just had you do 24. 24 is C. Cool. Okay, we're not done. We're done the genetics part. Genetics is done. As long as you finish the answers to genetics 3, you're done. Pardon me? 23 is B. Sorry, didn't show up. It's there. Thank you for pointing that out. Now turn to page 115 in the workbook. This is chemistry review. Yay! Mr. Cunha, we want more of chemistry and genetics. All of it. $115. Now look. It says here, with these equations, you need your periodic table. I'm going to look at mine at the right here. You can flip to the one to the back of your workbook if you need it. You have, the question is, first of all, classify it and complete it. Now, we've classified it. Completing it is just one step further. I need to walk you through that. I am not going to balance these today. I'll come back to these after we've completed it next day and balance them. Let's look at this. 1A is C2H2 plus O2. Don't worry about completing it yet. I want you to classify it. What type of reaction? Doesn't matter. Let's see if you remember anything. Good. Wow, you got it. Very good. Now, listen, this is the reasons why. You have here, this is called a hydrocarbon. A hydrocarbon is simply made up of hydrogen and carbon. Alternatively, you could have something that looks like this. Okay, that isn't, gents, I don't have time. This is an alcohol. It looks just like a hydrocarbon except it's got an extra oxygen tacked on. So this is a 7 here. See, oh, sorry. See, yeah, it's a 7. It's propanol, okay? Now, it's an alcohol because it's got the extra oxygen. Other than that, it looks like a hydrocarbon. The point is this. If you have either combination of a hydrocarbon or an alcohol, you have what's called combustion. Combustion always results in the following. Carbon dioxide plus water. Those are the necessary products of a combustion reaction. What's a combustion reaction? Hydrocarbon plus oxygen, or alcohol plus oxygen. Okay? We'll come back to this later and balance them all. Next one, let's see if you can figure out what type of reaction it is. Classify it. Don't tell me. You can do it. We're looking for a pattern for most of these. Not so much with combustion, but definitely with the others. Is it an element plus a compound? Is it a compound plus a compound? It's an element plus a compound. Yeah. Yeah. That's the pattern. Element plus compound means it's synthesis. Oh, sorry, single replacement. Single replacement. Now, To predict the products, let's look at the following. We have the element is a nonmetal. I'll put NM. Now, you could...
Please excuse the interruption. Could Adrian McKenzie come to the office? Adrian McKenzie to the office, please.
As far as the pattern for element plus compound, you could have either a nonmetal plus a compound or a metal plus a compound. It's important to notice which one because that will determine the products. That will allow you to predict the products. If it's a nonmetal, the nonmetal, in this case chlorine, will kick out the other nonmetal. It will replace the other nonmetal. So the products are the following. If you kick out the iodine, you're left with KCl. The formula is determined by making sure that the charges are balanced by crisscrossing. In this case, it's easy to predict. They're both +1 and -1. So the obvious outcome is just KCl. It won't always be obvious. You have to make sure that the final product has its charges balanced by crisscrossing. In this case, it was easy to predict. The iodine was kicked out, which means now it's all by itself. When an element's all by itself, you then have to ask yourself the question, is it diatomic or not? What do I mean by that? By diatomic, I mean, is it one of the following elements in the inverted L located in the periodic table? So what does that look like? That inverted L contains the following: nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Any of those elements, as you can see, iodine and chlorine are one of them. If they end up by themselves, you draw them or you write them as diatomic. You don't write I, you write I2. I'll show you the difference in a second as to when you don't have to write a diatomic. Okay? That's why chlorine here on the left side is written as Cl2, not Cl. It's more stable when one chlorine joins with another chlorine to form Cl2. Okay? Now let's look at a similar example. Can you get that for me? Okay? This is single replacement. Why? Because it combines an element plus a compound. However, the difference between this expression here and the one above is this element is a metal. I'll just put M. Stands for metal. What does that mean? Knowing that it's a metal means you now know which one it replaces in the compound. It replaces the metal. Metal replaces metal. Non-metal replaces non-metal. Which means the following. Your new compound is Na. You have to balance this. I'm doing it quickly. NaI. That's actually the formula. It is not a simple replacement in terms of numbers. You have to go back and check to make sure the charge is balanced. They do in this case. Okay? Plus, what gets kicked out is the potassium. Potassium is not, it is not K2. It's just K. It's not diatomic. Why is that? Because potassium is not in this inverted L. Go back to the inverted L. Potassium is not anywhere in that list. Therefore, you just write K, not K2. Okay? Next, C. It looks like it, but is that a hydrocarbon? Is aluminum a hydrocarbon? No. So let's look at the pattern. Element plus element, they come together. Two elements coming together. It's okay, you're guessing, it's okay. It's good to try. Two come together to form one. Synthesis. When you see two elements, synthesis. What is it? It gives us, let's look at what it gives us. Well, it is AO, yes. It is ALO, but it does not, writing it as ALO, it does not balance the charge. You have to crisscross to balance the charge. So crisscrossing gives us Al2O3. Make sure you have the right formula. Next step would be to balance it. I'm not going to do that today. You've got the extra time now to either complete the assignment, or if you want to complete page 115, you can do either. Okay? We'll continue next day.